All right, so today we're going to go on to the next module, which is encapsulation, and in C that means using structures. But as a segue into that, and as a kind of a review of what we've done over the last couple of weeks, both file I/O and string processing, I'd like to do a motivating exercise here, where we've got a bunch of CSV data based on books, and then we're going to compute various statistics about these books. So for example, we're going to find the best book according to Goodreads.com ratings, the worst book, all the books by Frank Herbert, etc. Here's what the data looks like. It's very, very simple. There are only 5 tokens, right? The first token is the title of the book. So for example, Harry Potter and the Deathly Hallows. The second token is going to be the author's first name. The third token is their last name. The release year, and then here is the Goodreads aggregate average rating. I think it's on a 5-point scale, so 0 to 5 stars. Okay. Now we've kind of cheated here in that the first line is telling you exactly how many records there are, and so what we're going to do is we're going to process this file line by line. We are going to process each line to pull out each one of those 5 pieces of data. And then ultimately, we're going to do one or more or all of these reports. You can imagine that you could do dozens of reports just on this very, very simple data. For example, you could find all books by a certain person. You could find the oldest book, the newest book, the aggregate rating of all the books, etc. So you could come up with a lot of different variations with just 20 records and only 5 pieces of data each, right? So let's go ahead and get started. I just want to open up the file, of course. Open the file for input processing. Right? To do that, I need, of course, a file star, right? And I'll just call it F. And I'm going to call fopen. Right? The file that I want to open is in the current working directory. It's the same directory, and it's called books.csv, right? Right there. Okay. And I'm going to open it up for what purposes? Reading or writing? Am I going to be reading this file, or am I going to be writing to this file? Reading, so it's R. Right? Now, immediately, before I get started on anything else, step 3, or the last step, what do I do to make sure I clean up after myself? I close it, right? Close F, right? Close the file, ... Okay, all right? Otherwise, we're going to process this file line by line. And remember that we're cheating by putting the number of records at the top of the file. So let's read in that first line. Right? Read in the first line to determine the number of records, ... All right? So I'm going to go ahead and have, first of all, I need a buffer. Right? I need a buffer to hold each line, because I'm going to read this line by line. And so I'm going to use forgets. F, file, get, S is being a string, right? And I will also potentially need a pointer to tell me when I'm at the end of the file. Remember F get S? That returns null when you've reached the end of the file, okay? What are the arguments to forgets, right? You've got 3 of them. You're going to have the string, the buffer that you want to read into, the maximum number of bytes to read -1, because it'll take care of the null terminating character for you, and then finally the file that you're reading from, F in this case. Right? That gives me the first line. Right? The first line is just simply a number, an integer. How do I convert that to an integer? I want to know what the number of records is. A to I, right? You've been using that since week 2 or week 1 or 2 or something, right? Where you are converting a string, right? You converted command line arguments, which we now know are strings, into an integer. In this case, it's whatever's stored in buffer. Okay. Now that I know the number of records, right, do I need to use a while loop to go all the way to the end of the file? If I did that, would I be reading valid records for these last 8 or so lines? Nope. So if we're going to cheat and tell you exactly how many records there are in the file, right, then pay attention to it, right? Only read that many records. And if I'm only going to be reading that many records, then what kind of a loop should I use? A for loop. For int I equals 0, I is less than n, or number of records, I plus plus. If you're actually storing things into an array like we did for you in your lab yesterday or Tuesday, then of course you would need that index variable. Right? So what I'm going to do is I'm going to read the next line. Right? And that's simply just going to be line is equal to forgets of buffer 1000 and f. Right? Same exact call as the first call to it. Right? Now I want to process the line. Right? I want to split it up into its tokens. Right? Its tokens being the title, the first name of the author, the last name of the author, the year, and the Goodreads average rating. Okay. So how do I split a string up into its tokens? How do I tokenize it? strtoke, right? And that takes the first argument, or the first time that you call it, you tokenize you give it the string that you want to tokenize, in this case buffer, the delimiter that you want to tokenize it on, and in this case the delimiter is commas because it's CSV, right? Comma separated value data. Right? That returns a pointer to a string. So char pointer, what would I call it? Title, because that's what it is. Right? There we go. That's the first one. The second one is going to be the author's first name. Author first name. strtoke of buffer with a comma. Is that correct? The second time that I call strtoke, do I provide it the string that you're trying to tokenize? Nope. It'll just go right back to the beginning. So I use null. There we go. There. Now I've spelled it correct. All right, author first name, author last name. Right, there we go. The next one is going to be that's 1, 2, 3. The fourth one is going to be the year, which is an integer, right? Year is equal to strtoke of null and a delimiter. Is that correct? Now strtoke returns a string. How do I change a string into an integer again? A to I, right? Sorry, yeah, go ahead.
Can you explain the strtoke null thing again?
So the first time that you call it, you need to provide the string that you're tokenizing. Each subsequent time that you call it, you provide null to tell it to continue operating on the same string. So in this case, there are 5 tokens, right? It begins at the beginning. Right? If you told it continue, like if you told it buffer right here instead, buffer, right? Where would it go? It would go right back to the first token, right? That's not how this string tokenization works. No, right? By giving it null, whatever I called you before, like I'm telling strtoke, whatever string you were tokenizing before, it remembers that it was buffer, right? And continue tokenizing that same string so that I get the first token, second, third, fourth, right? Yep. There is another strtoke r, which is a re-entrant function. We won't talk about that. That's because that gets into thread safety, and we're not going to talk about threads yet. All right. Another way that you could have done this is by storing it in a string, right? Year as a string, year string. There we go. And then I could pass in the year string to a to I to convert it over to an integer. Right? What I did, I just did it in 1 line before. I'll go ahead and do it in 2 lines now. The last token, of course, will be the rating string, strtoke of null and comma. Right? And now that's a double, right? Because it's 4.62, 3.5, right? So the actual rating will be a to I, a to f, rating string. Yeah, there we go. Now, before I bother with any of these reports, which is the whole purpose of what we started out with here, I want to make sure that I'm actually reading the file in line by line correctly here. To do that, I'm simply going to print it out. So printf %s by %s comma %s, right? Released in %d with a rating of %f. Right? So I'm going to print all those things out. The title. I'm going to go last name, comma, first name. So author, last name, author, first name. Then the year that it was released, year. And finally, the rating. Right. There we go. A long line, but I'm just going to print it out just as a sanity check here. GCC demo. Oops, buffer was undeclared. I declared it right there. Oh, duh. What did I need to do? Provide an actual value, char buffer. There we go. There, now it'll work. A dot out. Right. So if this works, it should read everything from Harry Potter by J.K. Rowling, released in 2007 with a rating of 4.62, all the way down to A Game of Thrones by Martin George, 1996, 4.45. And it looks like it works to me. 4.45. The first one is also Harry Potter and the Deathly Hallows by J.K. Rowling, Rowling, comma, J.K., released in 2007 with a rating of 4.62. All right. Now that I know that I'm reading the data incorrectly, that ends our review of file I/O and string processing. What is the best book? Now, what's the best book according to the Goodreads ratings based on the data that we have here? In other words, what is the best book with the highest value of the rating right here? Right? So tell me how you would go about doing that. An if statement, okay. If that rating is greater than the highest rating so far, all right, then I will say that rating is equal to the highest rating so far. Highest rating is equal to rating. Right? So I'll take that out. That was just pseudocode, right? Don't name your variable so far, right? The highest rating is equal to the rating. Great. Right? That means that I need this variable first of all, right? So let's go ahead and go up here before I get started processing the data, and let's declare that that variable. Always initialize your variables, right? Okay, I could put it by 0.0. Right? Why would that be a sensible default beginning value? Yeah, any of the books are going to be bigger than 0.0. If you want to be really paranoid and say that, well, there could be a book that all the books suck and they have all 0, right? Then you could go ahead and go with -1 as another flag value, right? We'll go ahead and go with 0. Okay, after we're done processing all the data, let's go ahead and print that out. Printf, the highest rated book is, well, what was the highest rated book? I'm not sure, but I know the rating has a rating of %F, end the line, right? And so highest rating. There we go. Now you probably have, you could look over the 20 values really quickly and determine that yourself, but that's because we have a small amount of data. If we had 20,000 values, would you be able to answer that question so quickly? Right? The highest rated book is, I don't know, with a rating of 4.62. Right? So what was it? I want the title of the highest rated book. Make another variable, title of highest rated book. Okay, that means that I'm going to have to create that variable up here along with the highest rating. It's going to be a string, right? And if I ever find a higher rated book, I will need to say that that string is equal to the title of whatever book that was. Is that how I deal with strings? No. strcpy into one string into another. Right? The equals operator will not work. It'll simply just change what it's pointing to. And if at any point you had a bug in your last lab where it was printing out Padres, 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 Padres all the time, it was probably because you were using the equals operator, the assignment operator. Right? And then you realize, wait, that's wrong, obviously, because not all the teams are Padres. What it was doing was it was taking the last piece of data that you wrote, because you were changing the pointer the entire time. Well, what was the last thing you changed it to? The last record, which happened to be the Padres. Right? All right, so str copy into that, and then we can print it. Right? I like to give myself a little bit more room here to offset the data so that we can clearly see that the highest rated book is Harry Potter and the Deathly Hallows with a rating of 4.62. Right? Now again, whether or not you agree with that, I certainly don't. But anyway, it's the highest rated book as far as the this data goes. Okay. Except who wrote it? All right, you know that, and anybody who's not been living under a rock knows that, but the computer don't know that, right? So, what was the highest rated book by, I don't know, right? So, what am I going to have to do to get that information? Make another variable, right? I'm going to have to make a variable for their last name and their first name. Oh, by the way, when was it released? Well, yeah, what did you say? Doesn't matter, right? Well, I want to know that information though, right? So yet another variable, yet another variable, yet another variable. Should I even go down this road any further? Probably not. Right? Instead, I should be thinking about encapsulation, right? Encapsulation, what is it? It is a way of grouping data together to form one logical unit, right? So built-in types like integer, double, char, or even like an entire character string or string, right? Those are very limiting. Not everything is a number, not everything is a character, not everything is a string. Instead, real-world entities like books, films, people, right, etc., are composed of multiple pieces of data. Encapsulation is when you group multiple pieces of data together into one object. We usually call them objects when we're in the context of an object-oriented programming language, or thing, right? And it allows you to deal with that thing as one thing. Instead of 5 pieces of data that are separate and spread all over the place, right? You've got you can take them all and you can group them into one book, one film, one student, whatever you're trying to model, right? And so the solution in C is going to be structures. Right? You can define a structure using the typedef struct keyword. Struct keyword. There we go. Right? Where have we seen typedef before? Enums, right? You can define your own enumerated type. You can define your own list. You can define your own structure using the same syntax, typedef struct, right? We'll look at an example here in a second, but encapsulation is actually, more formally here, is a mechanism by which you can, I'm going to cut and paste this because it's a list, right? Group pieces of data together into one logical unit. That's what we're going to do. 2, protect that data from the outside world. And 3, group functionality that acts on that data with that data. Now, this is the definition today, right? This is the object-oriented programming definition that came along in the 80s, 90s, whatever you want to talk, wherever you want to credit it. Unfortunately, C predates that. So C only has weak encapsulation, right? C only supports number 1, right? It has weak encapsulation. There we go. Right? The grouping of pieces of data together into one logical unit. Unfortunately, there's no way to protect that data from the outside world like you do in a programming language like, say, Java, where you've got these keywords called private and protected, right? That allows you to protect that data from the outside world, outside that object. You also have methods in Java that allows you to put those methods in the same class, right? C does not have either one of those two things. So C only has weak encapsulation, number 1. Various programming languages of various object-oriented programming degree will provide 1, 2, or all of these 3 things. Java, for example, provides all 3. Something like Python only provides number 1 and number 3. Right? They omit number 2. Right? They don't have the protection of data. Anybody have or what did I say? Python, right? I said Python? That's what I meant, right? Python. Python only supports number 1 and number 3. Anybody with a Python background? Right? So you can do whatever you want with any variable anywhere, right? And that's why we don't have the protection of that data outside of a class in Python. Right? So in that sense, it supports a little bit stronger encapsulation, but not full encapsulation. All right, I'm going to come over here and I'm going to start solving this problem a little bit differently. I want to start by modeling the problem, modeling what a book is. Touchbook.ch and touchbook.c. All I've done here is created two book files here. I'm going to go ahead and go to the header file, and I'm going to start defining what a book is by using typedef struct. Right? There we go. It's very, very similar to typedef enum, right? But we're defining a structure instead. At the end, we provide a name for that thing, right? And note here that I am using upper camel casing. That's a modern convention that I would encourage you to use. Certainly, if you were in an object-oriented programming language like, say Java, you would definitely be using that, right? Book. Should I call it books? Yeah, there's only one, right? Don't pluralize it. Also, don't pluralize it because English is a terrible language to pluralize things. Many languages are terrible languages to pluralize things because sometimes you add an S, sometimes you add ES, sometimes you change the Y to an I and add ES, right? Sometimes it's a completely different word entirely, right? Person, persons, or people, right? Multiple different options there. All right, so what is a book? Well, I mean, a book could be a lot of things, right? It could be an ISBN, it could be a release, a bunch of different pieces of data. But as far as we're concerned, what is a book? It's a title. It's an author, first name, last name. It's a release year. It's a Goodreads rating, et cetera, right? So let's put all those things over here, right? Char star title, right? Char star author first name. Char star author last name. What's the pattern that I'm following here? So it's in a typedef enum, it was a list of things, so we delimited it by commas. This is not a list of things. It is a statement of what a book is. So these are variables. And what comes at the end of variable declarations? Semicolons. Good. And then int release year. And finally, double rating. Right? Goodreads.com rating. Okay. Excellent. Right? That defines a book. Anytime you have more than one piece of data, right, that represents something, that should be, if it's only one piece of data, then that's all it is, right? It's just an integer, or it's just a double, or it's just a char star. But when you have two pieces of data, three pieces of data, four pieces of data, that should be screaming out to you, put me in a structure, collect this data into one thing. Which has me thinking now, author, first name and last name. Maybe I want their birth date too. Maybe I want a bunch of other data associated with them. In any case, even if I don't want any other data, what do I have here? Two pieces of data that represents one thing, a person. What should this be screaming out to me? Make a structure. Typedef, struct, author. There we go. And put those two things into the author structure. And I changed the name because author first name, author last name, that's kind of redundant. Now, how do I take care of that up here? Author. I will be redundant there. You could go with author, the author, right? That's kind of stupid. You could go with author A, but you're not being paid by the characters, so make it clearer, author. That's why we follow this convention. If you are naming all of your types with upper camel casing and all of your variables with lower camel casing, you will not get them confused. Okay? Or it's less likely that you're going to get them confused. Let's see if this compiles. I don't have high hopes for it. Right? Oh, you know what? It does, but that's because I'm not including the book.h header file here. Note that there's really no code in here, right? I'm just including the header file and then compiling it. Right? Now it's complaining. Author, I don't know what the heck an author is. Why? Because it comes after. You start at the top, you're a dumb compiler, or the dumb compiler says, okay, I know what a char star is, I know what an int is, I know what a double is, but wait a second, what the hell's an author? Right? If you're going to declare something and use it, you have to declare it before you use it. So the order matters here. Now, there are ways around that. There are alternative ways of declaring structures. I'm showing you only one way here for consistency. Don't worry about the other ways. Okay? All right. Now it should compile. And it does. Excellent. I want some more information, right? I'm designing my objects. I'm designing my structures before I even start, playing around with the actual code to process data over here. Okay? Release year. I'm thinking that I want more data now. Right? Now, I asked the other class, or one of the other sections, probably too young to have been in a standing in line waiting for the book to come out and buy it on the first day. Probably you were not of that age. But I don't know. Was anybody? Was anybody there on day one? Oh, okay, there we go. Do you remember the date?
No.
Okay.
That's been a while.
Release date of Harry Potter Deathly Hollows? Is that like that? Hollows? Yeah, there we go. July 21st. Right? So how do I represent that over here if I want to represent the entire date? Right? So remember it was July 21st, 2007. Oh, okay. Hold on to that thought yet. Right? What are some ways of representing a date? Like I just did, right? Write it out as a string. July 21st, 2007. Except that often you'll see dates with an abbreviation. Often you'll see dates without the ordinal. Often you'll see dates without the comma and any other kind of a combination thereof, right? If you're an American, you will write it like what? 7/21/2007. If you're a European, how will you write it? 21/7/2007, right? Guess what? They're all wrong, right? Only computer scientists get it right because we actually came up with a standard, ISO 8601. Right? Here's the standard date time format. I don't want that. I want Wikipedia. There we go. There it is. Right? Year, month, day, with leading zeros. Right? With a T, and then if you want the actual time, with a T separator here, 24-hour time with a Greenwich Mean offset. Right? That is completely unambiguous, and it is completely lexicographically correct. Right? That if you sorted this according to, say, the ASCII text table, the time will be past to future, and there will be no ambiguities whatsoever because you've got lexicographic sorting here. Right? That's what the ISO 8601 standard is all about. Right? Only computer scientists get it correct. Right? None of those are correct. If you're going to do this as a string, char star release date, right? Then you would use a formatting that looks more like this. July 21st, right? There we go. So remember that in the future. Anytime you sign a document, be a good computer scientist and make sure that you are signing it with the ISO standard of 2007-721, right? And then point out whoever you're talking to that they've been doing it wrong, right? What's another way of doing it? It's also computer science-y oriented. Hold on to that. That'll be the final solution, right? Yeah, the Unix epoch. Let's see, this one. This is the one I want. What time is it right now? Right now it is 16674965589 and counting. Right? That is the number of seconds that have passed, or number of milliseconds, or whatever it is, since January 1st, 1970. That's the Unix epoch. Right? So in other words, it's one number. You can go back in time with negative numbers. So all you need to do is choose an epoch, right? That's what we've done, right? It's been 2022 years since the chosen epoch for the Gregorian calendar, right? Oh, this is the Unix calendar, right? This is the Unix epoch. Eventually, we will run out, right? Unix epoch. Actually, it's the year 2038 problem. There we go. That's in 16 years? Oh, wait, it's 2022, right? Yeah, 16 years from now, right? In 16 years, we will eventually have overflow here because we'll get to 2.147 billion, which is the largest value by a 2's complement assigned in a 32-bit integer. And suddenly it will become, there we go, 1901 again. Right? Because very similar to the year 2000 problem, right? If you only use 2 numbers to represent the year, you get to 1999, you go to 2000, it's not 2000, it's 1900 again. Right? And so this is what happens when you've got overflow. Most systems use a long, so a 64-bit number. So, for example, if we were to use long release date, we'd be safe for several trillion years, right? Then we'd have a year 1 trillion problem eventually, right? So those are 2 options. What's another option? What you said and what you said, right? Let's go ahead and make another structure. Type def struct, and I'll call it date. Right? What is a date? Well, it's a year, it's a month, and it's a day. Right? Okay. Now I can go ahead and what date? Release date. There we go. And use that down here. Remember, order matters. Why would I want to do something like this? Well, you'd want to do something like this because you could reuse it. Date of birth of the author, right? The release date of your book, right? The reissue date of your book. I don't know, the authorship date of the book, right? If you've got dates all over the place, you put it into a structure and reuse it. Just like if you have the same piece of code over and over and over again, that should be yelling to you to put it into a function so that you can reuse that function. Right? Now this is data oriented. If you've got the same pieces of data over and over and over again, that's yelling out to you to put it into a structure and reuse that structure. Right? Let's make sure that this works. Excellent, it does. All right, let's go ahead and take this over to our notes here. Right? And defining structures. So here's the example. Right? And here are our observations. Right? You use the keywords type def struct. Right? And it's shortened because if you could save 3 characters in the 1970s, 80s, you did so. Right? You use type def struct and within curly brackets provide a list, and I'll put that in quotes there because it's not actually a list, of the structure's member variables is what we call them. Okay? They are a member of that structure. Each one is delimited by, or ended, I should say, ended with a semicolon. Semicolon. The name of the structure is provided at the end with a semicolon. Right? The name should follow an upper camel casing convention to set it off from the variables that you're using. Member variables should use a lower camel casing convention. What else? When a structure contains another structure, it is known as composition. Right. So to understand that, let's go over to our Python tutor. Right. And I'm going to take all this code here. Python tutor. There we go. No. Python tutor C version. Right. And let's take a look at what it looks like when you actually create one of these things. Now that I've created a variable type called book, it's just like creating an integer. Int x is equal to 42, right? That's built into the language. It knows what an integer is. Now that I've created a structure called a book, it also knows what a book is. Book B. All right? Let's go ahead and visualize this execution here. All right? There it is. There's my book. It's a big box of data. Right? The title has an uninitialized pointer here, right? That's the title of the book. The author is another structure. So there's another box there that contains the first name and the last name and the date of birth. The date of birth is another box that contains additional data, year, month, and day. So I've got a box within a box within a bigger box. Box within a box within a box. Right? The rating is its own, and then the release date is another structure over here. Okay? So let's edit this. Now, as a preview of how to use this, how can we set one of those things? So this will be our model for Harry Potter and the Deathly Hallows, right? B dot release year is equal to 2000. Or sorry, that's release year. Let's go with rating. What was the rating? 4.62, something like that. Let's visualize that and understand how it works, or the syntax at least here in a second. Right? All right. Next, we've got our book B. Note here that the rating is a question mark. The moment that I go past this line, it'll be filled in with 4.62. How did I do that? So the rating is a member variable of this book instance. Okay. So when you create an element, when you declare an instance of your structure, you can access its member variables using the direct component selection operator. What does that look like? It's a period, but what does it look like? A dot. So forget about the indirect component selection operator. We call it a dot operator. Right? Right? So all you have to do is the book, with your variable name, dot, and then it takes you to whatever member variable you want. All right, come back over here. And, oops, I should have left the visualization up here. Let's predict, or tell me how am I going to update this release date here to 2007. Month is going to be July, and then the date is 4. Exactly, we chain them together, right? So, book, or the B in this case, B dot release date, it was release date, right? Yep, dot year is equal to 2007. So if I've got a box within a box within a box, right? You just use the component selection operator over and over again to chain into that box. B dot release date dot month is equal to July. B dot release date dot day is equal to, I think it was the 21st. Doesn't really matter. Right. There we go. And you'll see that each one of these pieces of data gets filled in. 2007, 7, and 21. Right? You're jumping from this box to each one of the boxes inside that box. Okay? That's the way to look at it. Something like this. That seems really tedious. Right? For example, if I come over here to the demo and I include my new book structure here, right? How do I go about using it? I've got the title, the author name, the last name, the year, et cetera, et cetera. How do I go about using it? Right? Book B, right? Now what do I have to do? B dot, B dot, B dot, all this stuff. Well, let's just do one, right? Let's go ahead and do at least the title. Does that look right? The title is what type? It's a string. Can you use the equals operator on a string? No. At least what do you have to do? strcpy. Right? Now, is that still right? Let's come over here to our visualization. There's the title right now. Right? What's the pointer pointing to? It doesn't point to anything, right? So if we were to just write this code, right? B.title, I'll go ahead and copy Harry Potter, what was it, 7 or 8, something, whatever, strcpy, right, there we go. Do I need to include the string library? No, I don't think so. Let's go ahead and visualize this, see if it works. Right. Come on. There we go. All right, so let's walk through this code. So the rating gets updated, right? Can I copy Harry Potter 7 into a pointer that's uninitialized? Nope. There. Use of uninitialized value of size 8, right? It's 8 because this is a pointer, 8 bytes for a pointer, and you can't copy into that because you haven't created enough memory for it. So what do I have to do? Allocate memory for it. B.title is equal to a call to malloc, right? Size of char times strlen of title plus 1, bad math, good math, done. Right? I have to do that for the first name, the last name. I have to do that for any string that I have. Gee, there must be a better way. Right? Well, first of all, could I replace these 2 lines of code here with that same deep string copy function that we've been using now for a couple times at least, right? Second of all, I'm going to have to do this for the first name, the last name, I won't have to do it for the year and the rating, right? But what I want to do is I want to create what's called a constructor, right? Constructors or factory functions. Right? So creating instances of creating instances of structures can be a lot of boilerplate code. Boilerplate, one word probably. Right? Boilerplate code. Instead, create a function to do the grunt work for you. This is known in object-oriented programming. This is known as a constructor. This would be a constructor. But this is not an object-oriented programming language, so in C, we sometimes call these factory functions. Why are they called factory functions? We give them the raw materials, and they produce whatever you're trying to create. Right? They take care of all the low-level details of allocating memory, copying over strings, et cetera, et cetera, et cetera. So that's what I want to do with the rest of our time here. Well, yeah, we'll have more than enough time here. Right? So let me go ahead and, in my header file here, define the prototype for this thing. Right? So this is a factory function that creates a book instances, book with a capital B, book instances, given the data provided. Right. So we'll worry about the return type here in a second, but what should I call this function? Bookmaker? I did look up the line, and this is the one time that I would probably bet in favor of Nebraska because the bookmakers made a 16-point spread in favor of Minnesota. Nobody follows, nobody gambles, baby. Right? Never mind. Nobody lost money this season betting against Nebraska, but this is the one time I would probably bet on them because that point spread is insane for Minnesota. Anyway. I don't want to call it bookmaker because that's gambling. What do I want to call it? Create book? Okay. Right. Why does it sound better though? It's a verb and then the direct object that you are creating, right? It's more how we would say it. Bookmaker, right? That tells me it's a noun, and I want my functions to be verbs, right? So create the book or make book or something like that, right? All right. So create book. What's the raw material to create a book, at least as far as our data is concerned here? Right? Those 5 things, right? So const char star title. Why did I put a const there? We're not changing it. Author, first name, right? Const char star author, last name, or then what was it? Release year, int release year. And finally, double rating. All right. Now, of course, I designed this book now to have a whole bunch of other data, but this is all the data that I have, so that's what I'll go with. Okay? Now, what should the return type be here? It could be book. Right? Think about how that's going to work, though. Right? Yeah, I'm going to make a book, and then I'm going to have to return a copy of it on the stack. Not that big of a deal because, you know, it's less than, it's probably 1, 2, 3, 4 times 4 by, or 1, 2, 3 times 4, that's 12 bytes right there. That's another 8 and another 8, so that's going to be 28 bytes total. And then we've got, what, another 8, so that's 36 that we're up to, another 8, and so that's 44. That's 44 bytes. Who cares, right? That's not that inefficient. What's an alternative, though? Yeah. Okay, you could make it. You could say, "I created a book and it's over there." Right? There's a pointer pointing to it by returning a pointer. But you know what kind of pointer it is? A book pointer. There's a book over there. There it is. Right? Go get it. Exactly. Right? All right. Also note here, another style is that I am indenting over. Right? I've aligned all of the arguments vertically. Why would you want to do something like that? So you can read it, right? You don't have this big, giant, long line, right? And if you have limited real estate on your screen like I do right here, that's a godsend, right? And even if you don't, then you're always, you know, going back and forth, scrolling back and forth to see everything, right? All right. So how do we go about doing this? Right. There we go. All right. So if you're going to create a pointer to a book, how do you create that book? Book star B is equal to something. Return B. Well, how did you create an array of integers? Malloc. How did you create an array of characters? Malloc. How do you create an array of one book? Right? Malloc. Exactly. I mean, that's how you do everything. Malloc, Malloc, Malloc. Right? Yeah, go ahead. That's exactly how we did the pixel thing. Yep. We had to use Malloc there, too, to create an array of pixels. A pixel was a structure, right? What would it have looked like? It would have looked like exactly like this date, but you have a red, green, and blue, right? And then it becomes a pixel instead. Undo, 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 undo. There we go. All right. All right, how many books do you want? Just one. How many bytes does a book take? However many bytes it takes, right? How many bytes does an integer take? Size of int. How many bytes does a double take? Size of double. How many bytes does a book take? Size of book, exactly. Right. Now, if you want to, you can go ahead and omit this one. I'm going to leave it there just to drive home the fact that we are only creating one book. This is not an array of books. If you want an array of books, you can do that, and we'll do that shortly when we get back to actually crunching this data. For now, we're making a library of books, exactly. Haha. All right. With that data, how can I go ahead and initialize everything? Right, well, it's going to look something like this, right, for the title. B.title is equal to that title, and then copy it over. Let's see if C likes this. Well, first of all, I've got to bring in what? Standard library to probably include the string library and anything else that you're using. They're fine. Right? Still doesn't like it. Right? B is a pointer. Did you need to use hyphen less than, greater than? Right? Remember that we called this the indirect component selection operator, or the direct component selection operator? Don't worry about that, right? It's the dot operator. Right? But that only works for regular old structures. B is not a regular old structure. B is a what? It's a pointer to a structure. So how do I take a pointer to something, dereference it, so that I turn it into a regular old structure? Dereferencing operator. Surround it with a parenthesis here because it has a lower priority in the PEMDAS rules, and then you can use your period. Right? So do the same thing here. Dereference, then you can use the period, the dot operator, and C is happy about that. That looks so ugly that C added some syntactic sugar here. You don't have to do the dereference and then dot, dereference dot everywhere. Instead, if you have a pointer to a structure, you can use the indirect component selection operator. But we're not going to use that word. What does it look like? Arrow. It's the arrow operator. Right? Okay? Arrow operator, arrow operator, arrow operator. Okay? Same thing with the author's first name, except that author first name is now in another structure, right? Author. So B's author, do I use the arrow operator or the dot operator here to get the first name? Why? Yeah, why dot? Book is the pointer, but the author in the book is a regular old structure. There we go. If you want to redesign it so that the author is also a pointer, you can do that. Right? That's what that would look like. We're not going to go do that though. Right? All right. Dot, dot, and then B's author first name. Author first name. I'm getting really tired of cutting and pasting these two lines though. What should I have done? Made a function, exactly. First name, last name. There we go. Last name, last name, last name. I'll leave that for an exercise for you though. And then finally, B's, what is it? B's rating is equal to rating. Right? Oh, then the release year. B's year, what was it called? Release year? Or release date, right? Which is another structure. Dot year is equal to release year. There. Lots of boilerplate stuff of putting one value in a variable into another value of a variable so that you can wrap it up into one structure. But by putting it into a function, I don't have to worry about that anymore, do I? All I need to do is say create book, and give it what it wants. Title, author, first name, author, last name, year, and rating. All done. Anytime that you want to create a book, you can do that now, right? Because you created a factory function. All right, well, down here, maybe another useful piece of functionality would be a print function, right? I want to print, here's a book. Print it out for me, right to the standard output. Okay? Let's go ahead and write that function now. Book to string. In a lot of object-oriented programming languages, they will have a toString function built in with some sort of a default behavior. Usually it involves the memory address of the object. We don't have such a luxury here. So book to string. I want a book. Do I want a book like that? Nope. I like pointers. Let's play with pointers. Right? Am I going to be making changes to that book if I'm just going to pre-printing it? Nope. So const. You can use the const keyword on anything you want, right? And then the compiler will detect changes and prevent them. Book to string. What will be my return type here? Oh yeah, okay, yeah, toString or book, print book? Print book, or which one of these do we actually want to write? Book to string. Yeah, it depends on what you want to do, right? So it gives you a string representation of the book. The second one does. That you can do whatever you want to do with it. If you want to print it as the standard output, you can. If you want to print it to a file, you can. If you want to print it to another string, you can. So which one of these seems more useful? For example, would print book be able to print it to a file? Nope. So it has less functionality than book to string. Let's do both, because this one is probably going to want to call this one. Right? So void and book to string. Well, if you're going to convert this over to a string representation, what's its return type going to be? Char star. Right? There we go. So to do documentation, to do documentation. Okay. Let's do both of them with the remaining time here. We have plenty of time to do it. Right? Let's take the more general one first. Actually, no, let's take the easier one first. Assuming that we've already written book to string, what should I do? Char star s is equal to book to string of b system dot printf %s and the line s. Right? There, that's it. You gave me a string, I printed it out, and I returned back from the function. Always be thinking, though. Yeah, what's the problem? Oh, okay. If b is so error handling. If b is equal to null, I don't know. We could say printf null. That's what I would do, right? And then return. Don't do the rest of this stuff. What else is a problem, though? This is memory that's been dynamically allocated. We print it, we're done with it. What do we do with it? Free it. There we go. Then return. Now let's do the actual meat and potatoes of this. All right? Book to string. I want it to look something like this. So I'm going to cut and paste this. Now I don't want it to print to the standard output. I want it to print to a, not to a file, but to a string, sprintf. And there's my string, s. I didn't have to do anything special at all, did I? Except for I don't have title anymore. I have book's title. I have the book's author's last name. Right? I have the book's author's first name. Right? I have the book's year. And I have the book's rating. There we go. I don't have a string, though, yet, do I? Right. So help me out. How big is that string going to be? Char s. Yeah, 1 million? That's big enough, right? That's certainly big enough. Am I going to be able to do that? That's a static string on the stack, overflowing the stack because you only have 8 megs. Right. Is that big enough? No. Is that big enough? Maybe reasonably. If you want to, you can go ahead and do the math, right? So how many characters am I going to want? If I print out the title, strlen of B's title, right? Plus, if I print out the author's last name, the string length of the author's last name, right? strlen of that. Oops. Plus, do the rest of them. However, how many more characters do I want? Well, I want that space. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't want to do this anymore. Right? Yes, that's big enough. Right? Can I return that? Can I return statically allocated memory that's on the stack in the stack frame? When I return from that function, what happens to that stack frame? It dies. It gets popped off the stack and goes away. So let me go ahead and now create char star str is equal to char star malloc size of however big that s is, or sorry, char plus or times strlen of s plus 1 for the null terminating character. Good math, right? And then I can strcpy into str s, and then I can return the string instead, str. Do you see what I did there? Right? I avoided all that mathy stuff, right? Adding up all those things and getting it just right, right? I just said, okay, well, let's go ahead and do a reasonable overestimate. This is an unreasonable overestimate. This is an unreasonable underestimate. But 1,000, that's probably good enough, right? I then used sprintf to copy and format it exactly how I wanted, right? It's not going to use all 1,000 of these characters, 999 minus for the null terminating character, right? But then I dynamically allocate just enough memory for that formatting, plus 1 for the null terminating character, copy it in, and then return that string. Right? Do I have to free s before I return? Nope. In fact, I can't. Can you free stack memory and give it back to the operating system? Nope, that's a stack smashing event. Right? So this is wrong. This one is right. Right. Okay. There we go. Implicit declaration of printf, fine. What should I have included? Standard input-output library if you're going to do stuff like that. I should probably go back and take care of a bunch of error handling to do. Also add some error handling. Right. Dot, dot, dot. Right. Oops, B year. It's not year. What is it called? Yeah, it's a release date. Release date dot year. There we go. That should be good. Yep, there we go. All right. So let's come over here to the demo, and let's use that now. So I've created the book, right? And I'm also doing my report over here, right? And printf, instead of doing this, I'll go ahead and say print book and pass in B. There we go. Much cleaner code because now I've offloaded the heavy lifting to a function and it takes care of all that stuff for me. So GCC demo and book.o all together. Same exact behavior as before. Right? Print book. I guess that put. I don't want an inline character in my toString function. Right? If you want to put it in when you print it to the standard output, go ahead. But I don't want these this double spacing here. Right? It looks nice. Okay. Actually, I would go back and change it even more. We can make it even look nicer. Right? We'll just go ahead and say that, let's assume that there are no more than 50 characters in the title. I won't take by anymore. I'll just go ahead and put it into a column format here. Released in %20D with a rating of, and then space over here, 0.2F, because we only have 2 decimals of accuracy. There we go. GCC book. GCC everything together, and now it looks more like a actual table, right? Not perfect, but I can go back in and change that and align everything up, right? There's the title, there's the author. What's wrong with the year? 20D. Why are you more or less? Maybe only 10D, and maybe only 40 over here. There we go. That'll get it to or GCC book first, and then that stuff, and then run it. And you can play around with it and get it to align up it perfectly if you want to, using all those tricks. Right? That's a little bit better. Still not great over here, but I can take care of that later. Right? Now it looks like a table, right? And you can align that table. You can sort things, which is what we're going to do after recursion. But we're next week on Tuesday, we'll go ahead and look at some more utility functions. We have a way to create things. We have a way of printing things out. We have a way of converting them to strings, right? We have all the basics so far. I want some more utility functions to deal with this stuff. Okay? All right. I'll see you in Hack later on.